Welcome to all. Today I will discuss about the topic two-dimensional array. An array of arrays is known as two-dimensional array. Two-dimensional array is also known as a matrix. A matrix can be represented as a table of rows and columns. The syntax of a two-dimensional array is data type, array name of rows, columns. An example, int a of 2, 3. Here 2 is the row size and 3 is the column size. Next, there are two ways to initialize a two-dimensional arrays. First way, int a of 2, 3. Here a is the array name and 2 is the row size and 3 is the column size. 10, 11, 12 in the curly braces, first row, and 14, 15, 16 is the second row elements. And also we can declare as a of row size is not given and the column size is 3. And the second way is a of 2, 3 equal to curly braces 10, 11, 12, 14, 15 and 16. There is no separation among the elements. And also we can write as a of row size is not given and column size is 3. Here the row 1 and column 1 the element is 10 and row 1 and column 2 the element is 11 and row 1 and column 3 the element is 12. Next, the structure of two-dimensional array of size a of 3, 5. Here the first element is a of 0, 0 and the second one a of 0, 1. Next a of 0, 2, etc. The first row represented as a of 0 and the column is a of 0, 0. When we initialize a one-dimensional array, we need not to specify the size of it. But in two-dimensional array, we should specify the second dimension, even if you are specifying elements during the declaration. Here, some valid declarations are given. The first one, int a of 2, 2. Here, the row size is 2 and the column size is 2. Then this is a valid declaration. Second example, a of row size is not given and column size is 2 equal to 1, 2, 3, 4 are the elements of this array. It's also a valid declaration. Next, a of row size and column size are not given, so this is an invalid declaration because you must specify the second dimension. And another example, a of 2, that is row size is given and column size is not given. It is also an invalid declaration because should specify the second dimension. First program is related to two-dimensional arrays. Program to read a matrix of size m by n. Our program begins with void main. The variable declaration, then variable declarations. Here m and n are the row size and column size. A of 2020 is the array. The row size is 20 and the column size is 20. These are the maximum size. I and j are used for reading row and column size. Uh, so I and j are the indexes. Then first print a message to console, enter the order of matrix, then uh, m and n read from the console. First for loop is I equal to 0, I less than m, I plus plus. Here m is the row size. Then inside the first for loop, next for loop is started. J equal to 0, j less than n, j plus plus. Here n is the column size. Then printf enter the element, and a message is printed to the console. Then scanf percentage d ampersand a of ij. Here we scan the array elements. First I equal to 0 and I less than m. Consider this example. Enter the order of matrix. We enter 2 and 3. 2 is the row size and 3 is the column size. Then first comes to the for loop. I equal to 0, I less than m. M is the 2 and the condition is satisfied, entered into the body of the for loop. In body of the for loop, next for loop is started. Here j equal to 0, j less than n, n is the 3, condition is satisfied, then enter into the body of the for loop, printf, enter the element, scanf percentage d ampersand a of ij. That is the first element 1. Enter the element 1 can be get from the console. Then exit from the this for loop and coming to the header part of this for loop, j plus plus, that is increment j by 1. Then check the condition, j less than n, n is the 3, j is the j increment by 1 and j equal to 1, 1 less than 3, condition is satisfied, then it entered into the body of the for loop. Message enter the element is printed to the console. Then scanf the second element can be fetched from the console. Second element is 2, and then it come exit from the body of the for loop and uh, comes here, that is j plus plus. J is incremented by 1 and the value of j is 2. 2 less than n, n is 3, 2 less than n, okay, the condition is satisfied, then it entered into the body of the for loop, enter the element, the third element is entered, enter the element, element is 3. Next it exit from this for loop and comes on j plus plus, j equal to 3, 3 less than n, that is n equal to 3, 3 less than 3, condition is false, then it exit from this for loop and moving to I plus plus. I plus plus, that is I equal to 1, then 1 less than m. M is 2, 1 less than m, condition is satisfied, then it's entered the body of the for loop, that is next for is started, j equal to 0, j less than n. Now j is 0, n is 3, 0 less than 3, condition is satisfied, then it entered into the this for loop, that is element enter the element into This message is printed into the console and scan the element of A of ij, that is the second row um, elements second row element, that is 4 is the first element of the second row. Next, this for loop is continued as earlier as I mentioned. Then when this condition is false, then it exits from this for loop and comes on to the, this printf. That is, we will print the um, entered value as a matrix. First for loop, that is I equal to 0, I less than m. M is the row size. Then the second for loop, I j equal to 0, j less than n is the column size. Then entered into this for loop, printf %d slash t. Here we used slash t to print this space among the first element and the second element of first row. Then print a of ij, first element is will be printed, and then comes to the j plus plus. The condition is checked, j less than n, condition is satisfied, then print a of ij. The second element 2 will be printed, and next it will move to the j plus plus, then j less than n, condition satisfied, then print the third element of first row. 3 is printed. Next, j increment and j less than n, that is 3 less than 3. The condition is false and exit from this for loop, then print slash n. So our cursor will move on this position because we want to print our second row in this position. So it exits from this for loop and comes on this I plus plus. Then condition will be checked, I less than m. I is 1 and m is 2. 1 less than m, the condition is satisfied. Then enter into the body of this for loop, that is the second for loop, j equal to 0, j less than n, and j equal to 0 less than n is the 3, condition is satisfied. Then comes into the for loops body, %d slash t. Slash t, already I mentioned that slash t is used to um, print the space among the elements. A of ij, first element of this second row will be printed, that is 4. Next moves to j plus plus, then condition checked, j less than n. The condition is true, that is 1 less than 3. Then comes to the print of portion, then it print 5. Then exit from this for loop and coming to the j plus plus, then condition is checked, j less than n, condition is satisfied, then print a of ij, that is 6. The next is to find the transpose of a matrix. Transpose of a matrix is a new matrix that is obtained by exchanging the rows and columns of the original matrix. Consider the example, a 2 by 2 matrix 1 2 3 4. The transpose of the above matrix is 1 3 2 4. The upper triangle is shifted to the lower triangle and the lower triangle is shifted to the upper triangle. Let us go through the indexes. A of 0 0 equal to 1, A of 0 1 equal to 2, and A of 1 0 equal to 3, and A of 1 1 equal to 4. After the conversion, we are getting the transpose. In T of 0 1 equal to 3, that is A of 1 0 element will be placed, and T of 1 0 equal to 2, the element of A of 0 1 will be placed. We observe here, just by replacing the indexes I and j will get the transpose. Next is a program to read a matrix of size m by n and display its transpose. Our program is start from void main, then declare different variables which is used in this program. Here a row, column, two arrays A and T. Then ij. I is used for the index of row and j is used for the index of column. Then we scan row and column size. This to for loop or this code snippet is used to read array elements. I have already mentioned in the previous slide how to read a two-dimensional array elements and display that element in the matrix form. This code snippet is used to scan array elements, and this code snippet is used for display the array elements in a matrix form. Next, this nested for loop is used to find transpose of a matrix. Here, the rows of the original matrix becomes the columns in the transpose, and columns of the original matrix becomes the rows in the transpose. So we can assign it into the transpose matrix. That means just replacing the I and j values. This just copy the row into the columns and columns into the rows. After finding the transpose, we print the same. We assigned the rows to j and rows to j and columns to I, because initially we entered the values 2 rows and 3 columns. 2 rows and 3 columns. After transposing the matrix, will become 3 columns and 3 rows and 2 columns. That's why we assigned j value to row and column value to I.